Hi guys, this is Dr. Bruno Gobato. I'm at home now and I'm recording this video. This is a student request. We're going to show how we can draw, how we can design a implant. For this video we are going to show how we can design a reverse total shoulder arthroplasty implant. We are using the glenosphere, so only the scapular side, because the humerus is hard to draw. We are using the Rhino software. The Rhino software uses solids as reference, so this is a beginner's way how to do that. There are easier ways using directly CAD softwares like Fusion. They are very accurate, but I'm going to show the visual way how we can create. So let's resize a little bit here. First of all, let's show here our delta reverse total shoulder. What is a reverse total shoulder? Here we can see the humeral side and the glenoid side. Here we can see this picture, and here we can see in a better way. So here this is what we're going to draw. This is what we're going to design. This is a half sphere, as you can see here. It's a half sphere. It's a cylinder that corresponds to the central peg. Four other cylinders that are the screws, and a cylinder that is the peg. The base plate. So this is what we are going to transform into a 3D file. In this picture we can see it easily. We have here the base plate, the normal and the extended base plate. So we are going to design this cylinder right here, which is actually the base plate, the central cylinder, which is the peg, and the screws. Here I have one design that I have already done, and I'm going to show you right there. So here we have in green the glenosphere. Okay, so in glenosphere it's a 38 glenosphere in green. This is very simple. This is a half sphere. In yellow we have the base plate, as you can see here. This is it's a cylinder, cutted cylinder. This big yellow cylinder is the central peg of the glenosphere. I'm just showing this. So this is the central peg, this is the base plate, and the other red cylinders, these four red cylinders, corresponds to the location of the screws. And we made this blue cylinder, which is the central pin guide. This is important for the surgery. This does not has in the model, but this is important for the surgery. When you see this design, you can see that we have created the screws. They not start, the cylinder screws, they not start here in the base plate. We prolong it to the articular side because it's important to understand the direction of the screws. So it's important to understand how they go, how they are directed in surgery. This is important for the central pin guide. But let's start. Here we are open our CAD software. This will be the same for every CAD software. You can do this on Tinkercad. We can do this on Windows 3D Builder. It's very simple. We have a video showing how to design. It's a quick video, but we have a video showing how to design this. But first of all, we need to take measurements. So we have opened here the glenosphere, the Puy-Synthes. This is just an example. So we must take some measurements, okay? So we know here they have shown us that we have a 38 millimeter glenosphere and a 42 millimeter glenosphere. We're going to create a 38 millimeter glenosphere. And we have here the metaglen, okay, the base plate, the metaglen. So we have here a peg with 18 millimeters, 24, 30, 36, and 42. okay? And we have the screws. The screws doesn't it doesn't matter for us right now. We know, it's not written right here, that the base plate has 28 millimeters in diameter, okay? 28 millimeters in diameter. Just let's write that. We can do this by hand, but I suggest taking pictures of the implant. So here I took a picture of this implant. This is from the actual patent. It's online, it's available online, but you can have your own pictures, okay? It's no problem. I think I have here some pictures. This is from the patent. Let me see here if I have some other pictures to show you guys how we can design this using pictures. Here is an example of a Johnson. So for the Johnson implant, we took pictures with a scale, okay, with a ruler, and we use this as a reference. So this can be done using only pictures. Most of the times I do like that, okay? And here with this picture, also we know for sure the distance of the peg and also the diameter of the peg. But we're going to use a image just like that. We know so for sure that this cylinder has 28 millimeters, okay? So let's start right there. We have here our views. I'm going to start with the top view, and I'm going to do a very simple tip here. I'm going to select grid options, okay, dimensions, grid, okay, and here it says that each one grid is 1 centimeter. Maybe the unit will be not okay, but we can scale in 10 or it will be okay. So the grid line count, this is the tip I suggest. We're going to choose 28, which is the diameter of our glenosphere. So here we have a 28 diameter. So we are just clicking here on solid, and let's create a cylinder. We're going to select the central point of the cylinder, and now we can choose the diameter. We can draw it by hand, or we can just right click here and set 28 millimeter diameter. And now we just need to do the offset. Okay, let's change the offset for the correct offset as we have measured in our PDF, okay? So now we have here the central. This will be corresponded to the base plate, okay? I'm going to go back. I'm going to show a different way to do that. So we are going to create here a Rhino, view, background bitmap and place. Okay, we're going to select where our file is. So let's go to our 3D Delta Extend PDFs, and this is the view we want. Now we can place the image just right there. Okay, hit done, and now we can draw over the image. So we know this is the central pin guide, solid, cylinder. Let's use the image as reference here. We can use the image, or we can do the radius just as we done the other way. We are going to choose right here, and the offset here in the front view. Okay, now we have a base plate. Now we are going to design the central pin guide. I'm going to change colors. Okay, let's design solid cylinder, another cylinder in the center. just like that, and we're going to do a cylinder, a longer cylinder. Let's move to the middle, and now we have the base plate and the central pin guide. Now we are going to design the central peg. Okay, I'm going to change colors again. Solid, cylinder, here central pin guide. We can choose the diameter as well as we want, and the offset. The offset is 18, if I'm sure. So here we have 18. Okay. So now we have the base plate, the central pin guide, and the peg. And now we can draw, if we want, the screws. Let's change colors. Let's draw a screw, cylinder. Let's select in the middle. Let's draw here. We can choose the correct diameter of our drill, okay, if we want. But we are designing here in a quicker way. So let's draw here, and let's draw the screws. I do like to move the screws from the inner part in the outer part. And now we just click copy and paste and move to the other ways. Let's copy and paste. Okay. Copy and paste again. And now we already have our base plate with the central pin guide, with the peg and the screws. Now we just need to create our glenosphere, okay? We are choosing a 38 glenosphere, okay? So we are going to, let's change color again. Let's choose this, okay, solid. Now we're going to select a sphere, solid sphere, the central pin guide here. And now we can draw the sphere, just like that, or we can choose the radius. The radius of the glenosphere is 30, just let me check. I have forgotten. I just have forgotten the glenospheres. I think we have a 42 and we have a 38. Okay, we have a 38, so we need a 19 radius sphere. So let's do again, sphere, central pin, click, radius, 19, okay, hit OK, and now we have the sphere. But the glenosphere is not a complete sphere. The glenosphere is a half sphere. So let's cut this sphere in half. Where? Just in the middle of the glenosphere. So we're going to design a square, a box here over the glenosphere. Okay, it doesn't matter. So here we have a box, okay. Let's just move it. Oh, I think here is okay. Here is okay. Now we're going to delete the other part of this sphere. So we're going to select this sphere, solid, difference, and now we click the square. And now we have the glenosphere cut it, and here we have our glenosphere. We have the base plate, the glenosphere, and the central pin guide. The glenosphere is in the other side, so let's rotate it actually 180 degrees and move it to the correct location. Now it's okay. As you can see here, now we have our glenosphere. It's a 38 glenosphere. We have our base plate, our peg, our central pin guide. And if we want to plan the surgery, it's quite easy. I'm going to group all together, Ctrl G. Let's import a scapula. Let's choose a scapula from our files. I'm going to choose a scapula I'm working just right now. Just a second. This is not a arthritic scapula. It's actually a normal scapula. Okay, I think I'm going to import. Okay, now we have our scapula and we can plan the surgery as we want. Just rotate, move it to the location you want. This patient has a dysplasic posterior scapula, and here we know we have the surgery planned. Okay, so here we have the scapula, the location of the screws, the pin guide, and we're going to create a very easy patient-specific guide. Okay, let's assume that this is the location this is the location we want. So we're going to delete the glenosphere. Let's assume this is the location we want. We are going to delete everything else. We can check the location of the screws. We can move the location of the screws. Here we're going to rotate in order for this screw has a better position. We can rotate any screw. We know for this arthroplasty we can rotate until 10 degrees. So we can rotate, and by doing that we can check the direction of the screws, okay, as you can see here, and we can create a patient-specific guide. Let's do that. Let's delete everything, except the central pin guide. Okay, so here we have our scapula with a central pin guide. Let's draw a very simple square around the scapula. So let's draw a box here over the center, just like that. Okay, just like that. I'm going to be a little bit bigger. I'm going to do a very simple guide. Of course, we can design better guides, but let's do just like that. Let's move, and here we have the central pin guide and the design we have just placed. So let's check the box. Let's select Boolean operations difference. Let's select our scapula and our central pin guide and hit enter. And here we have our central pin guide, as you can see here, that will fit perfectly into the scapula and shows us the direction for our central pin guide reverse total shoulder arthroplasty. And this is how we design actually every implant we do. Generally we take pictures. Sometimes we use the patents we found from Google. Sometimes we use only the PDF, and maybe if your manufacturer sends you, we can use it directly. Thank you for this video. This is a very quick video, but I think it was step by step. You can pause, you can test, and this is how we do in actually any CAD software. Bye bye.